Welcome to our YouTube channel students, e-learning hub by Udgam Welfare Foundation. In this video series, we are discussing about the case studies on definite integrals. If you have missed our previous two case studies, then I am going to request you that you can please watch those videos, as it is going to help you a lot in revision of your concept related to definite integrals. In this video, we are going to discuss our next case study, that is case study number 3. Whether you are a CBSE board student or whether you are a ISC board student, it is going to help you a lot. So let's move forward and discuss our third case study. So student, this is our third case study, which states that Aryan was solving definite integral using a weekend study session. His teacher had recently explained the substitution method in class and also revised key properties such as linearity, symmetry and splitting the interval. Aryan found some integrals easier when he made a proper substitution such as x equals to a minus t or x equal to sine theta in trigo integrals. He was also taught how to apply the identity like a to b fx dx is equal to a to b f of a plus b minus x, which is a definite integral property, and the importance of recognizing whether a function is even or odd to use fx is even when minus a to fx dx equals to twice of 0 to a fx dx. As these are the properties of definite integrals, and these case studies are going to help you out in revision of your concept related to this particular chapter. Aryan's goal was to use substitution and properties to simplify integrals instead of expanding or directly integrating. Answer the following question based on the Aryan's approach. So that was our third case study. Now we are going to discuss 5 MCQs based on this case study as per the board standard. So students, this is our first problem related to this particular case study. We have to evaluate 0 to pi by 2 sin x into cos x. And how we are going to tackle this particular integral? We can simply introduce 2 here, 1 by 2, that is division and multiplication by 2 sin x cos x. I am not writing the limits here right now. First we are targeting the integral only. So 2 sin x cos x will give you 1 by 2 sin 2x. Now we can simply integrate this particular trigo function, that is cos 2x, that is negative of cos 2x upon 2. Now we can simply put upper limit and lower limit, right? So here we are getting minus cos 2x by 2 and upper limit is pi by 2 and lower limit is 0. Very simple. Now we can simply take this 2 common, which will give you 1 by 4. Now minus cos 2x minus cos 2 into upper limit, that is pi by 2, and minus of minus cos 2 into 0, obviously 0 here. This will give you 1 by 4. This is going to give you cos pi. Cos pi is minus 1. Minus minus plus. So plus 1 minus. This is cos 0. Cos 0 is 1. Again minus 1 plus 1. So this will give you plus 1. So 1 plus 1 is 2. So 2 by 4 is what? 1 by 2. So this is your answer. That is 1 by 2. So option number A is our correct answer here. Very simple. Now let's move towards question number 2. So students, this is our question number 2, where we have to evaluate using substitution 0 to 1 by 1 plus x square here. Obviously the question states here you have to evaluate using substitution, but it is not compulsory that you can use the substitution method. You can simply use the property here, that is integration of 1 upon 1 plus x square is what? This is tan inverse x. Very simple. So you can simply write tan inverse x 1 0, right? So tan inverse 1 minus tan inverse of 0. So tan inverse 1 is what? Pi by 4 minus 0, which is pi by 4 only. So you are going to get option number A. That is option number A is the correct answer here. Now let's move towards question number 3 here. So here comes our question number 3, students. We have to evaluate using identity 0 to 2 1 upon x plus 1. So integration of 1 upon x plus 1, integration of 1 upon x plus 1 is nothing but log of x plus 1. Very simple. So log of x plus 1, and the upper limit is 2, lower limit is 0. So this will give you log 2 plus 1 minus log of 0 plus 1. So here you will be getting log 3 minus log 1, and value of log 1 is 0. So log 3 is your correct answer. So option number B is the correct answer here. Very simple. Now let's move towards question number 4. So here comes our question number 4. We have to evaluate using substitution 0 to pi by 2 1 upon 1 plus sin x. So if you see any integral in the form 1 upon a plus b sin x, or 1 upon a plus b cos x, or 1 upon a plus b sin x plus c cos x, right? We need to substitute sin x in terms of half angle of tan theta. That is, let sin x equals to 2 tan t by 2 upon 1 plus tan square t by 2, or half angle you can say, right? X, you can write it x. So 2 tan x by 2 upon 1 plus tan square x by 2. We can simply write this way. So what is going to give us here? 0 to pi by 2. So this term will go to the numerator, 1 plus tan square x by 2, and in the denominator you will see terms like this, plus 2 tan x by 2. So here you can see that you are going to get these type of terms here. So 1 plus tan square x by 2 is nothing but sec square x by 2 upon, so this is going to give you what? 1 plus tan x by 2 whole square. Very simple, 1 plus tan x by 2 whole square. Now if you put the denominator, that is 1 plus tan x by 2 is equal to t, then you are going to get as a derivative what? Tan x by 2's derivative is sec square x by 2 into half. So this will be your derivative of tan x by 2. So you can write it this way, 2 into dt upon t square. So this will be your question, as we have substituted what? This term as t. This is basically what? This is your t. So now we are getting only 1 upon t square. So integration of t square is what? Let me make some space here. So integration of t square is minus 2 plus 1 upon minus 2 plus 1. So here you will get t raised to the power minus 1 upon minus 1. As we have substituted 1 plus tan x by 2 is equal to t, so we can simply change our limits. So upper limit was pi by 2. So if we put here pi by 2, that is tan pi by 4. So 1 plus 1 is 2. So t is equal to 2 here for the upper limit. And if you put the lower limit 0, that is 1. So lower limit is equal to 1. So we can simply put 2 here and 1 here. Very simple. So here we also have this 2. So we can write this 2 here. Now we can write it this way. We can take this negative term outside, that is minus 2 of 1 upon t and 2 to 1. So it is going to give you what? Minus 2, that is 1 upon 2 minus 1. Again this is minus half. So it is going to give you minus half here. So which is 1 only. So your answer is 1 here. Very simple. So let's check out whether we are getting any option correct or not. So here we are having option number B, which is the correct answer here. Very simple. I hope the concept is clear. Now let's move towards question number 5. So students, this is our next question, which states that fx is a continuous function and satisfy this, evaluate 0 to 1 fx dx. As we know, the property of integral like 0 to a fx dx, or we can simply put twice of a, is equal to twice of 0 to a fx dx. Very simple. So if we substitute or if we put this particular type of property here in these results, we can say, so we can write this particular function as twice of 0 to 0.5 or 1 by 2 into fx dx. Very simple. So if we match our options, then we can see that option number B is the correct answer here. So student, that was the final question of this case study, that is case study number 3. And if you like the video, then please share and subscribe our video so that other students will also get benefited. And if you are interested in doing online tests, then these online tests are free of cost and available on our website, which is udgamwelfarefoundation.com, and these are based on different chapters and is going to help you out in how to tackle your 1 marker section, which comprises of 20% weightage of the entire board exam. So that's all in this particular video. We are going to meet in our next video. Till then, goodbye and take care.